Exercise 10.2, question number 1. From a point Q, the length of the tangent to a circle is 24 cm and the distance of Q from the center is 25 cm. The radius of the circle is, so let us first draw a figure for this one. So solving exercise 10.2, question number 1. So solution 1, we will draw a figure. So this is circle and let this be a tangent. From a point Q, the length of the tangent to a circle is 24 centimeter. So length of the tangent is 24 centimeters. So let this point be Q, and the distance of Q from the center, and let the center be O, and the point at which the tangent is touching the circle be P. So OP is there. Then we'll join O and Q. Distance of Q from the center. So this is 25 centimeter. Now we have to find the radius of the circle, that is OP. So here OP equal to radius. OP is the radius and PQ is, what is PQ? PQ is the tangent. So therefore, by theorem 10.1, what we can say? OP is perpendicular to PQ. That means we can apply Pythagoras theorem in triangle OPQ. Therefore, in right triangle OPQ, OQ square is equal to OP square plus PQ square, and this we are obtaining by using Pythagoras theorem. So this will give us OQ is 25, putting the value 25 square equal to OP is not known to us, so that we'll write as it is plus PQ, that is 24 square. So square of 25 is, squaring 25 will be getting 625 equal to, we are having OP square plus 576, and this will give us 625 minus 576 equal to OP square. Therefore, we will get OP square equal to 49, and taking the square root both sides, we will be getting, therefore OP equal to 7. And what is the unit given here? Centimeter. So always it is must to write the unit. So OP is equal to 7 centimeter. We will not write simply 7 centimeter. So the radius of the circle is 7 centimeter. So with this, question number 1 is over, and the correct option in this case will be A. Now let us go in question number 2, exercise 10.2, question number 2. So we will be doing question number 2, question 2, exercise 10.2. So solving question number 2 now. Solution 2. So we are having the figure here, and we have to obtain the value of P, T, Q, and TP and TQ are the tangents in this case. So here PT and QT are tangents to the given circle, and OP and OQ are the radii of the circle. Therefore, we know that the tangent is always perpendicular to the radius of the point of contact. Therefore, OP is perpendicular to PT and OQ is perpendicular to T. Therefore, we can say that angle P equal to 90 degree and angle Q equal to 90 degrees. And we know that the sum of all the angles of a quadrilateral is 360 degrees. Therefore, in quadrilateral OPTQ, what we will get, because angle P and angle Q, let us see here, angle P plus angle Q. equal to 90 plus 90, and that will be equal to 180 degree. And therefore, because the total sum of all the four angles of a quadrilateral is 60, we can say that therefore angle O plus angle T equal to 180 degree, because sum of all angles of a quadrilateral, sum of all angles of a quadrilateral is how much? 360 degree. So now what is given to us? Angle O is given to us. So therefore we put the value of angle O, that is 110 degree, plus what is angle T, that is not known to us, angle T equal to 180 degree. Therefore we can say that angle T equal to 180 degree minus 110 degree, and this will give us angle T equal to 70 degree. So our correct answer in this case is option number B. So option B is the correct answer. Question 3, exercise 10.2. If tangents PA and PB from a point P to a circle with center O are inclined to each other at angle of 80 degree, then angle PO is equal to. So first of all we'll draw a figure for this. So we'll be drawing figure. So we'll draw a circle, a rough figure we can draw, and here point P will take, and let PA and PB be the two tangents. So suppose this A and let this be B, and O be the center of the circle. So now what is given to us is the tangents P and PB from a point P to a circle with center O are inclined to each other at an angle of 80 degree, that is, this is 80 degree. Here angle APB equal to 80 degree. So what we'll do to obtain our answer, we'll do construction, we'll join O and P. So construction, join O and P, join O and P. So we'll join O and P. Now we'll prove that triangle PAO and triangle PBO are congruent. How we can do? Very simple. Angle A and angle B both are 90 degree. Why they are 90 degree? Because OA is the radius and PA is the tangent. At the point of contact we know that the radius is always perpendicular to the tangent. So here now let us solve this one. Here OA is perpendicular to AP, OB is perpendicular to AP, and therefore we can say that angle A equal to 90 degree, angle B equal to 90 degree. Why? Because of theorem 10.1 which says that the radius is always perpendicular to the tangent, at the point of contact, Now we will be going in triangle AOP. So in triangle AOP and triangle BOP, we can see that OP is equal to OP, common side. Next one, we can also see that AO is equal to BO. Why? Because they are radii of the same circle. This is our AO and this is BO. Both are the radii of the same circle. So radii of same circle. Next, let this be 1. And angle A equal to angle B. From where? From 1. Therefore, we can say that triangle AOP is congruent to triangle BOP, and Therefore, we can say, suppose say let this be say angle 1 and this be 2. Therefore, angle 1 equal to angle 2 by CPCT. Now next we will be going in also what we are having is also angle APB is equal to 80 degree, that is given to us. Therefore, angle 1 equal to angle 2 equal to 40 degree. Here from the figure also we can see this combined. Combined is 80 degree. So, both will be 40 and 40 because they are equal. Angle 1 and angle 2 are equal. So, both angle 1 and angle 2 will be half of 80 degree. Now, we will go in right triangle OAP. So, in right triangle OAP, angle O plus angle A plus angle P equal to 180 degree. Therefore, what is our angle O? That is what we have to find. So, angle O will keep as it is, plus what is angle A, that is 90 degree from here, plus what is angle P? Angle P is nothing but angle 1. So, that is equal to 40 degree equal to 180 degree. Therefore, we can say that angle O plus 130 degree is equal to 180 degree. Therefore, angle O is equal to 50 degree. So, we can say that therefore, angle AOP, therefore, angle AOP is equal to 50 degree, and this is our final answer for question number 3, exercise 10.2. So, with this it is complete. Question 4, exercise 10.2. Prove that the tangents drawn at the ends of a diameter of a circle are parallel. So, solving question number 4, here L and M are tangents to the circle, at A and B respectively, and AB is the diameter. So, now by theorem 10.1 we know that the radius is always perpendicular to the tangent at the point of contact. So, what we will be getting is angle A will be 90 degree and angle B will be also 90 degree. Here angle A equal to 90 degree, angle B equal to 90 degree. Why? Because tangent is always perpendicular. Tangent is always perpendicular to the radius at the point of contact. So, now we can see that for since if we add angle A and angle B, what we get total 180 degree, and we know that whenever the sum of interior angles on same side of a transversal is 180 degree, the lines are parallel. So, here angle A plus angle B equal to 180 degree. So, angle A plus angle B, what we are getting? 180 degree. And how we are getting 180 degree? That is equal to 90 plus 90, and that is equal to 180 degree. Therefore, we can say that L is parallel to M. Why? Because if the sum of interior angles, on the same side of transversal, is 180 degree, the lines are parallel. Then the lines are parallel. So, with this, our question number 4, exercise 10.2 is complete. Question 5, exercise 10.2. Prove that the perpendicular at the point of contact with the tangent to a circle passes through the center. So, solving question number 5, here L is tangent to the circle. L is tangent to the circle at point P, and L is perpendicular to M. So, this is given to us to prove. To prove, what we have to prove? We have to prove that prove that the perpendicular at the point of contact with the tangent to the circle passes through the center. So, what we have to prove that M passes through center of the circle. So, let O be center of the circle. O be center of the circle, and we do not know whether it lies on M or not. So, for time being, let us suppose that it is not lying on the line M. So, let this be point O. Now, what we will do is join O and P. Join O and P. So, we will join O and P. So, let us join O and P. So, this is our, we have joined O and P. Now, what will happen? Suppose this is our, that is O. Now, joining O and P. So, what is OP? OP will be the radius. So, OP equal to radius. Therefore, OP equal to radius, and we know from theorem 10.1 that the radius is always perpendicular to the tangent at point of contact. Since the radius is always perpendicular to the tangent at the point of contact. Therefore, we can say that OP is perpendicular to L. So, let this be 1, and also what we are having, what is given to us, also M is perpendicular to L, and where it is perpendicular at point P, So, this is our second one, and what we get from that, that is OP and M both are perpendicular to line L at point P, but this is possible only if, see here from figure also you can see that, otherwise suppose we take any point here, say A, so we will be getting OPA equal to 90 degree and this is also 90 degree. That is not possible unless these two angles are same, that is this angle and this angle, unless they are same, it is not possible. So, the only possibility is that O should lie on M, that is the perpendicular always passes through the center of the circle. So, that is what we will write. So, from 1 and 2, therefore from 1 and 2, we conclude that this is possible only if O, that is the center of the circle, that is if O, center of circle lies on M, that is the perpendicular to the tangent, and what is the tangent? Perpendicular to the tangent L at point P. So, this is our solution of question number 5. So, with this question number 5 is complete, and it says that clearly as discussed, this point O should lie on M, then only this case is possible, otherwise it will not be possible. So, with this question number 5 is complete. Question 6, exercise 10.5. the length of a tangent from a point A at distance 5 cm from the center of the circle is 4 cm. Find the radius of the circle. Solving question number 6. So first we'll draw a rough figure for this. So this is our circle, and the length of the tangent from the point A at distance 5 cm from the center of the circle is 4 cm. Suppose this is the center of the circle, and there is a point, say this A, and so OA is 5 cm, and suppose it's the tangent, and let the tangent be at point P to the circle. So this is the kind of figure which we are getting, and we have to obtain the value of OP, and the length of the tangent from a point A at distance of 5 cm from the center of the circle is 4 cm. So this is the tangent length of this is 4 cm. Now we know that the radius is always perpendicular to the tangent at the point of contact. So therefore we can say that angle OPA equal to 90 degree. Therefore in right triangle OPA, if we apply the Pythagoras theorem, we will get OA square is equal to OP square plus PA square, and this will give us 5 square equal to OP square is not known to us, so we will write as it is, plus PA is 4 square. Therefore 25 equal to OP square plus 16. Now if you simplify this further, we will get, therefore 25 minus 16 equal to OP square. This implies 9 is equal to OP square. Therefore we can say that OP equal to 3. Therefore the radius is equal to 3 centimeter. So this is the answer of question number 6, exercise 10.5. Question 7, exercise 10.2. Two concentric circles are of radii 5 cm and 3 cm. Find the length of the chord of the larger circle which touches the smaller circle. So solving question number 7. What are concentric circles? Two or more circles having the same center are known as concentric circles. So let us draw a figure for them. So this is our first circle, and inside this we'll draw one more circle. So these are the two concentric circles because they have the same center, say O. Now it says that find the length of the chord of the larger circle which touches the smaller circle. So let's draw a chord here. So this point AB, point A and point B, joining them will be getting the chord, and let it touch the smaller circle at, say, point P. So we'll join O and P. Now what is given to us? The concentric circles are of radii 5 cm and 3 cm. So OP will be of 3 cm because it is the radius of the smaller circle, and let us join O and A. So that will be the radius of the bigger circle, so it will be 5 cm. Now what it says that the chord AB, here chord AB touches the smaller circle, at point P, circle at point P. So it is only touching the circle. Therefore we can say that, therefore AB is tangent to the smaller circle. AB is tangent to the smaller circle, at point P, and therefore we can say that OP is perpendicular to AB because we know that the radius is perpendicular to the tangent at the point of contact. Now therefore we can say that angle APO equal to 90 degree. Now we'll go in right triangle APO and applying that Pythagoras theorem. So therefore in right triangle APO we will get AO square is equal to AP square plus OP square. Therefore, putting the value of AO, will be getting 5 square equal to AP square plus OP is 3. So 3 square will give us 25 equal to AP square plus 9. So therefore, we can say that AP square equal to 25 minus 9, that is 16. Therefore, AP equal to 4. Therefore, we can say that AP equal to 4 centimeter. Now, we know that if we draw a perpendicular from the center of any circle, then it bisects the chord. Here O is center for both the circles. So this is perpendicular here. So what we can say that OP will bisect AB. Here OP is perpendicular to AB. Therefore, we can say that AP is equal to PB. But what is AP for? Therefore, we can say that AP equal to PB equal to 4 centimeter. And therefore, the length of AB will be equal to, therefore, AB is equal to AP plus PB, and that is equal to 4 plus 4 equal to 8 centimeter. So what is the length of the chord? So the length of the chord, which is in the bigger circle, is for the bigger circle, that is AB, and touching the smaller circle at point P. So this is the solution of question number 7.